So now we're going to just recap and take a look at just how far we've come in this course, because actually we've come a long way. We've created a box pushing game here where the objective is for the player character to push the boxes onto the destination points, and we've created two levels, Scene 00 and Scene 01. What I have open in front of me here is the first level, Scene 00, and when the player completes this level they'll move to the next one, which is Scene 01. I've gone ahead and created Scene 01 off screen. Let's just maximize the viewport so you can see it better. And we have this level here. The starting point for the boxes are here and the destination points are over here, and the player begins here. And in creating this game we've relied on quite a whole wide range of features of Unity really. We've illuminated the environment here, the floors, the walls and the pillars, using light mapping, which is static lighting. And then we've gone ahead and created the boxes and the player character, and they are illuminated using light probes. We've also created some fiery torch particle systems that are on the wall, and we use that using the shuriken particle system. And also we've got the player character over here, which uses skeletal animation as well as inverse kinematics. So we've seen a whole lot in this course, and what I'm going to do now is just to jump back to the first level, Scene 00. And I'm going to start playing this level, and I'm going to complete it from start to end, and then I'm going to jump to the next level and complete that from start to end so that you can see how to complete both levels. I'm going to play these levels in a kind of time lapse so you can see in fast motion how I complete these levels, so we don't have to wait for too long. And then after doing that I'm going to examine where we go from here. So here I go. I'm going to just press play on the toolbar here, and I'm going to start playback of the game. Actually, I'm going to just stop playback. I'm going to switch to the game tab, maximize the viewport and press play so we can see it in a kind of full screen view. So I'm going to press play and, well, let's go. So you've now seen how to complete the game, both levels from start to end, but there's still one big problem and one feature I would like to implement in this game, and that is load and save game functionality. Right now, if the player reaches the second level, or if we add more levels and the player reaches those, then when they terminate the game they don't yet have the ability to jump back to the level they were last playing. And what I want to do now is I want to build in that load and save functionality. Now, because this is a casual puzzle game, it's the kind of thing that the player will be playing on a kind of casual basis, then I want to really just load back and restore the level as the game begins. So when the game starts, we want to check to see if the player had any previous session to restore, and if they do, we will restore that. Now, in creating this functionality, there are two main kinds of data that we will need to save. First, we want to remember which level the player was last on. So, for example, if they reach Scene 01 and then they terminate the game, we want to restore that level back to its initial state. That's the first thing that we want to do, so keep track of the level the player reached. But also within that level, the player will have maybe moved boxes or moved the player character. And we also want to save those changes too, so that we can not only restore the level, but we can restore the configuration of that level. So we want to restore the position of the boxes and the position of the player. To achieve this functionality, we're going to be using the Player Preferences class and also XML serialization. We're going to begin doing that in the next video, where we consider the Player Preferences class. So in this video I want to consider the Player Preferences class, and we're going to be using that to store which level the player was last on. Now I've jumped over here to a web browser window. If you look at the address bar, you can see I'm at the Unity documentation, playerprefs.html, and I'm looking at the player preferences class, and you can see quite a detailed description of that is provided for you in the Unity documentation. Now the player preferences class acts like a database that we can save data to and retrieve data from. It's really useful for storing small pieces of information, for example, the brightness of the screen, the resolution that the game should run at, and whether it should run in windowed mode or full screen mode. So it's really useful for kind of saving the options data that the player may specify. It's not so well suited to storing more detailed data such as the configuration of complete levels. We'll see how to do that later using XML files, but right now we're going to be using player preferences to store the level that the player was last on. Now this player preferences, it works like a database basically. If I scroll down, you can see that we've got a range of functions that we can use. I've got setString, setInt and setFloat, and these allow us to write values, write data to keys in the database. So I can set a string value, set an int and set a float, and we have these other functions, getFloat, getInt, getString, to read values from the database. And this data is stored persistently across game sessions. So if you store it to the computer, it doesn't matter if you exit the game. The next time you run the game, these values will still exist. You may wonder, where does it store this data on the local computer? Well, that depends on the operating system that you're using. If you're using Windows, you can see that it stores the data in the registry, and for other operating systems, it stores them in files in particular places. So you can visit this documentation if you're interested in seeing where exactly the data is stored. I'm going to jump back over to Unity and start using this class to save which level we reach. So I've jumped back into Unity here, and now we're going to get started at using the player preferences class to implement level loading functionality. You can see in front of you here that I have Scene 00 open, and this is the first level in the game, and it is loaded when the game begins. Now we have the game manager class, and there's an instance of this class in each and every level. So what we can do is we can add a start function to the class, which will query the player preferences database to see if the player has ever reached a later level before, and if they have, we can load that level. Otherwise, we leave the player on the current level. So what I'm going to do is I'm just going to open up MonoDevelop here, and here is the game manager class loaded in MonoDevelop, GameManager.C#, and right now it doesn't have a start function, so I'm going to be adding one of those. Let's just insert some spaces here. I'm going to type void start to create a start function, and we're going to get started at coding this function now using the player preferences class. So the first thing that we want to do is to query the player preferences database to see if there's been any level previously loaded. So what I'm going to do here is I'm going to type if and player preferences, and you can see here we have player prefs dot has key, which will check the database to see if there's an existing key, and I want to check for a key which is going to be called last level. I'm going to be using this key, which I've customized here, called last level. We're going to be using that to store the last level that the player reaches. It's going to be an integer property. So if the player preferences database has a key that is named last level, it means that the player has previously played this game and reached some level. We don't yet know which level that is, but we're going to find out. So let's retrieve the last level that the player has reached. So I'm going to type int last level, and we're going to choose player preferences dot get int, and I'm going to be getting the integer for the last level. So here we are. We say last level equals player preferences dot get int last level, which will retrieve a number indicating the last level we reached. And then we want to compare that last level. So I want to say if the last level is greater than the current level, which is application.loaded level, if it's greater than the current level, then that means the player has previously reached a level beyond the current one. And so we want to load that level. So I'm going to say application.load level. We've seen the load level function before, and we're going to be loading the last level. However, of course, if the player hasn't got the last level key in the player preferences database, or if they haven't reached a later level, then we just want to continue with the current level. And I'm going to set the current level to be the current last level. So we're going to say set int, and we're going to say last level, like so, and it's going to be set to application.loaded level, like so. And there, in creating those lines, we've created all the functionality that we need to resume playback from a later level. So I'm going to press Ctrl S on the keyboard, and in the next video we're going to be testing out this code and seeing how it works. So in the preceding movie we created level loading functionality using the player preferences class, and you can see that here in the start function for the game manager class. And what I've done off screen is I've gone ahead and completed the first level of the game and reached the second level. So if I just minimize mono develop, you can see that we've got the first level open here. Now if this level loading and saving functionality is working, it should mean that when I press play on the toolbar we reach the second level, and indeed it will do. Let's just press play to test that. And ta-da, you'll see that actually now when I press play, we're on the second level and we're not on the first level. And that's because this is the level that I last reached on a previous game session. So it has indeed stored that data and retrieved it back from the start function in the game manager. So everything is working quite nicely. But of course the problem is when I press play, we always begin back at the second level. What would happen if we wanted to just change the value manually and test out things? For example, what happens if I wanted to press play and go back to the first level during testing? Well, of course, we can easily change this value that's been stored in the player preferences database. On the Windows platform, you have to actually access the system registry to do that. I've just brought up here on the screen my registry editor. This is the registry editor for my system, and I've located the key here that you can see in the registry. It says last level, and it has some letters and numbers after it, but this is the last level value that has been stored for our project. And right now you can see over here in the data section that the value is set to 1 because that is the level that we have reached. I could just double click on this and change this value back to 0 and press OK. Let's just move that out of the way, press play on the toolbar, and now we go back to the very first level. Notice that update there on the key has really made a difference to that data. So I'm just going to press stop again. I can come back into here and change this value back to 1, choose OK, just move this out of the way again, press play on the toolbar, and now we're back to the second level, which was the original data. So that's looking pretty good. We've now got the player preferences class to implement this level loading functionality. What this will do is it will allow the player to reach absolutely any level they like in the game, and every time they resume playback it will load back that level. That's excellent, but of course the main problem that's facing us now is of course the player always begins back at their default location. The boxes are restored at their default location. These positions for the player and the boxes are still not saved. We're not going to be using the player preferences class to do that. Instead, we're going to be relying on XML. So in the previous movie, we created level loading functionality using the player preferences class, but one thing that functionality didn't do is it doesn't allow us to restore the positions of the player and the boxes in the level. It loads the level, but the player and the boxes are always set to their default or starting positions. And what I want to do now is I want to allow the player to resume the level and also to have the position of the player and the boxes restored as well. Now to do that we could use the player preferences class, but I don't think it's appropriate for that, and instead I'm going to be using a persistent file that we're going to save on the computer and load the data back from that file. Now there are different ways we can kind of implement this functionality in games. We could use a binary or proprietary file, and that's the most common method in games because it means that the user, the gamer, can't simply open up the file and edit the data. They can't really understand the data at all or change it, so it prevents them from cheating. But instead we're going to be using an XML file which is human readable, but it really makes debugging easier for the game. It allows us to open up the saved game data, have a look at it, inspect it and change it if necessary. At a later point we could convert the data to a binary system. So I'm going to be using XML data to save the game data here, and to do that we're going to be using the Mono framework, which effectively is an open source version of the .NET framework built into Unity, giving us a range of different classes we can use for saving data to the system. Now before I go ahead and do all of this, I want to inspect a sample XML file that I've created for this game, just to show you how exactly we're going to be storing the data. But before I do that, I'm just going to bring up a Windows Explorer, a Firefox window actually, and look at the text editor I'm going to be using to examine the XML, and this is Notepad++. You can download this application on Windows for free by going to notepad++.org, and this text editor gives you a range of different features that makes it very easy to examine and explore XML files. It gives you It gives you syntax highlighting and all kinds of other syntax folding as well, as we're going to see. So I'm just going to minimize Firefox here, and I'm going to bring up Notepad++, and we can see here that we've got our XML file, a sample XML file that I'm going to be using for the save game. So let's take a look at this XML file. So the root node in this file is the game data node, which encompasses all the save game data that we're going to be storing. There's a little plus next to that allowing me to expand it. And then as child objects beneath the game data node, we have BD and PD. BD refers to box data and PD refers to player data. So under the box data node, we're going to be storing the position of all the boxes in the level. So I'm going to click on the plus to expand that, and you can see we've got box data, box data, box data, box data, and so on. That's because I've already gone ahead in advance and created the functionality. This is actually a save game for the second level because we have 6 boxes here. So here is the first box, here's the next box, the third box, and so on. So if I expand, for example, the first box, you can see that we've got box transform and on destination. On destination is marked as false, meaning that when the game was saved, the box was not on its destination. But each of the boxes also has a box transform, which is effectively the position, orientation, and scale data for the box. So again, I can click plus to expand that, and you can see we have the X, Y, Z positions of the box, the rotation values in Euler angles, that is degrees, and we also have the scale X, Y, and Z factors here. So that's the data effectively for a single box, and we have that repeated for all of the other boxes saved from the level. So I'm just going to really close up the box data here. Let's expand the player data, and the only thing that we store for the player is the player transform data, again the X, Y, and Z values, the rotation, and the scale data. So effectively this is the data that we're going to be storing from a save game, and this is just one complete save game for the second level. It includes all the box data and the player data encompassed in the game data nodes. So that's the basic XML structure that we're going to be used for creating a save game. The question remains as to now how do we code that into our Unity project. We're going to get started at doing that next. So in this video we're going to get started with data serialization in Unity to save the position of the boxes and the player. To get started, I'm going to create a new class to do this. So I'm here in the Assets Script folder in the project panel. To create a new class, I'm going to right click and choose Create from the menu, and I'm going to choose C# Script. And I'm going to name this class Data Manager, like so, and press Enter on the keyboard. So now we've created a new Data Manager class, and I'm just going to open up this class in MonoDevelop. So I'm going to double click the Data Manager class. And here we are in MonoDevelop. So we have the beginnings of this class, Data Manager, derived from MonoBehavior. And the first thing I'm going to do is I'm just going to highlight the top section here where we are including various namespaces. We're going to be replacing these, and I've actually copied a number of namespaces to the clipboard. So let's just paste these in here with Control V, and we have a range of different namespaces here. So we have quite a few: Unity Engine, System.Collections, Collections.Generic, XML, XML Serialization, and System.io. We're going to be making use of all of these different namespaces. These contain various Mono Framework classes, which is an open source .NET implementation built into Unity. This contains a variety of different classes we'll use to effectively serialize our game data to an XML file. So what effectively is data serialization? Well, what it will allow us to do is effectively to take a class, we're going to be using the Data Manager class, to store all of the save game data, and it will allow us to stream or save a class to a file, and then later on we can load back that file and reconstruct the class just as it was when we saved it. That effectively is serialization in a nutshell. But the big problem with serialization, the thing that we have to take care with, is that not all the different data types can be serialized. Only a limited set of data types can be serialized, and so we need to keep track of the different types that are allowed and that we can serialize, and we can only use those. So we're going to be seeing cases of this later on. So right now I've created this Data Manager class, and we're going to be really getting started from this point. Now let's move on with the Data Manager. The first thing I'm going to do is I'm going to remove the MonoBehavior section here. Let's just put this onto a new line. I'm going to remove the mono behavior section because I'm not deriving from mono behavior. We're creating more or less a base kind of class here. And so that means I'm going to remove the update and the start functions from the class, so we begin from a completely empty class. Now we know, for example, that all the objects, the crates and the player, we're going to want to store the position, orientation and scale of those objects. So the problem with those classes, those objects, is that Unity uses vectors and quaternions to store that data, and that data is not serializable. So we're going to need to create our own class, our own structure to store that data using types that are serializable. So I'm going to do that now. I'm going to type public struct data transform. This is going to be a data structure that's going to keep track of all of the transform data that we're going to be using. So we need to store the X value, we need to store the Y value. This is the position data for the object. We're going to have to store the Z as well. We'll also need to store the rotation of the object. So we're going to be saying float, and I'm going to say rot X like so, public float rot Y. This rotation is going to be stored in Euler angles, that is degrees. So float rot Z. And we also want to store the scale of the object as well. Again, that's going to be scale X, float, public float, scale Y, and finally public float scale Z, like so. So in doing that, I've created these general float values which are serializable and we can use to store the transform data for the object. So I've created a data structure, data transform, and we're going to be using this structure to store the position data for the crates and for the player. So next what I want to do is to effectively add box data and player data. In the preceding movie, we created a data transform structure which stores the position, rotation and scale values for any object in the level, including the boxes and the player. And what I want to do now is I want to extend and add some new class definitions that is going to keep track of the box data and the player data. So to do this, I'm going to be pasting in some code so you don't have to see me typing in every single line. So let me just insert a new line here and press Ctrl V on the keyboard to paste in some new data. So I've created here a new box class which is called box data, and you can see that it relies on the data transform structure we've defined up here to keep track of the position, orientation and scale for any single box. So there will be an instantiation of this box data class for each and every box in the level to keep track of its position. We'll also keep track of whether it's on the destination at the time the game is saved. We've also got player data here, which really just keeps track of a data transform member to record the player position. I've created a separate class for this because of course we may at some later stage want to add additional data if we decide to add extra features to the game. And then finally down here we wrap up these structures together into a game data class, and this is going to be the actual class that we will serialize to an XML file. You may remember when we had a look at the XML file that the game data was the root XML node, and that really is significant. This represents all the game data wrapped up together. So first of all we have a list. We use a list data type to store a list of all the boxes in the level. This list class again is part of the mono framework, and we can use it to really keep track of a dynamic array. It doesn't matter how many boxes we have in the level, whether it's 1 or whether it's 10. This list structure will keep track of all the boxes in the level. It will be sized exactly to accommodate exactly the number of boxes that we need. So here we have a list structure for all the boxes in the level, and then we have the player data. So really this game data class brings it all together and wraps it all up. Now what I want to do now is I'm going to instantiate a new member to this data manager class. That's an instantiation of this game data that we're going to be serializing to a file. So I'm going to insert a new line under here and type public game data gd equals new game data, which instantiates a new game data class that you can see here, and that's looking pretty good. So we've got game data gd equals new game data. And the last thing that I want to do is scroll up to the top of the class here, the data manager class, and I'm just going to paste in this line here, XML root game data. And what this effectively does is it names the root node in the XML file. So we're going to be naming this XML game data. So what I'm going to do now is I'm just going to press Control S on the keyboard to save all of that information like so, and just minimize mono develop. Unity goes ahead and compiles that code. Everything so far is fine, but what we don't have a save and load function, which we're going to be using to actually save and load the data to and from an XML file. We have our data structures in place to store all of that save game data. The game manager is going to be calling upon a lot of this data here, but we need to implement some functions into the data manager class, such as a load and a save function, which will actually write all of this data to an XML file. We're going to be considering that in the next video. So now let's add load and save functions to our data manager class to save game data. So I'm just going to come over here and put my cursor here and paste in some new code, and then I'll explain what it does. So we have a save and a load function. Let's start with the save function. So with the save function, it accepts a parameter of string file name, which is going to specify a complete path on the system where the data should be saved into an XML file. Now on the first line, we create a new serializer object, which is of the type XML serializer. The XML serializer class is included in the Mono framework and is used to serialize a class to an XML file. We create a new instance of the XML serializer, and we have to tell the serializer which kind of class we want to serialize, and indeed we want to serialize a game data class, which we've declared up here. In the next line, we want to say, okay, we're saving this to a file, so we create a new file stream, and we're passing it the file name where the file is to be created, which is the argument put into the function here, and we're creating a new file by using the file mode.create argument. And then in the third line, finally, we use the XML serializer class created here to serialize to our file, which is indicated by a stream. We serialize the instance GD, which is an instance here of the game data class, and then finally we call the stream.close function to confirm that operation. So in this process here, using this save function, we save all of the game data here in the game data class to an XML file. Now the load function works very similarly. It's really just the same process, but in reverse. So we have in XML serializer class, and again we create that here, specifying type game data. We create a new file stream, but notice this time we're not creating a file as we did here with file mode.create. Instead we're calling file mode.open because we are opening an existing file on the hard drive. And then finally we use the serializer class to not serialize as we're doing here, but to deserialize the class. So we're taking that file and we're deserializing it as a type of game data, and the result is being stored in the game data variable, which is here in the data manager class. And then finally we call the stream.close function to confirm that operation, load back that data and close the file on the hard drive. So using the save and the load functions together, we can write data to an XML file and retrieve it back. But of course, this data, the save and load data, in combination with all of these data structures that we've created here, is not enough on its own. We've created the data structures to hold the game data. We've got the game data member here, which contains all of the game data we need to save. We've got the save and the load functions, but on its own, nothing actually populates this game data class. We create it in memory and it's initialized with all of its default values. We still need to take the game data actually in the level, the player and the crates, and we need to put them into this game data object so that we can actually record the state of the level. We're going to be doing that inside the game manager class. The game manager class is going to be handling this, the dealings with the game data here, and calling upon the save and the load functions to save and load the data respectively. So in the next video we're going to move away from the data manager class because this class is now completed. You can find it in the course companion files in the datamanager.c# file. Instead we're going to be moving back to the game manager class and implementing the saving functionality there.